Yes, uncle.
Okay, welcome students for this physics class. You know, we started 2 days back. We started with chemistry class. Yesterday we have had a weekly test. We thought we will have weekly test almost every week from the beginning itself. And today we have physics class. And Manish is a BTech engineer, and he took teaching as his profession, full time teaching. He's teaching for a CBSE schools. He's teaching for JEE and Neet. இதுக்கெல்லாமே physics teach பண்றாரு. He sits at Bombay, and he studied in Bangalore, Hyderabad, Coimbatore, and then he's joined a job in Bombay because his parents are in Bombay. That is the reason. He is basically from Coimbatore, but then he moved, and he knows how many languages, Manish? Seven, ah? Six, ah?
Six languages
Six
fluently.
languages, you know. இதெல்லாம் எது சொல்கிறேன்னா வாட் கைண்ட் ஆஃப் பர்சனாலிட்டி சிக்ஸ் லாங்குவேஜ் knows இங்கிலீஷ் தமிழ் தெலுங்கு கன்னடா ஹிந்தி வாட் இஸ் ஒன் மோர் மராட்டியா
Hindi, Malayalam,
Malayalam, okay. And not only that, Manish
Kannada
can
also.
teach mathematics, physics equally good, correct?
Physics, chemistry, and mathematics.
All three can teach equally good. See, the மாதிரி ஒரு rare combination of teachers எல்லாம் எங்கேயுமே இருக்கிற கஷ்டம். So he can teach because originally he taught for us chemistry. Am I correct?
When I initially joined
Joined
Igniting
for
Young
about six
Minds,
seven months. He taught only
so
chemistry. Apra
start
then we
okay,
have
okay.
asked him to teach physics because we got another person for chemistry like that. So just imagine, நீங்க பாருங்க class பார்த்தவே தெரியும். Let me not take much time. You can go ahead, Manish. The floor is yours.
Okay, thank you, uncle. Thank you for that wonderful introduction. And with that, we'll continue with today's lecture. And once again, good evening to one and all present here. We have, it's very happy to be, again reassociated after the break. Okay, so every year, and the results were also very good this time. And very proud also, to see my kids coming out with flying colors. That is a proud moment for, teachers. So definitely. And now let's move on. Okay, so we have different topics in physics which play a very important role for your competitive exams. Okay, among that 11th standard and 12th standard physics, we have certain topics which play a key role from where you have most important, or we say most wanted, questions come from those particular areas. So first we'll uh, concentrate and we'll try to cover those areas, and then we'll go to the ones which have very less attention or very few questions can probably come from that particular area. So for today, we'll start off with 12th, or you want me to start with 11th
11th,
basics?
11th. ஆமா அது நான் சொல்ல மறந்துட்டேன் Manish. For 2 3 months we will be having only the 11th portion. Then from
Okay,
September onward we'll go to the 12th portion.
okay, okay,
That is the
fine.
plan. Oh, I forgot to tell you. Okay.
Okay, okay, fine, okay, sure. So 11th also we will, we will cover first, because 11th, is like a bridge course, we can call it. So once we bridge the gap, it will be very easy. Once the foundation is all set, then we can, erect, tall structures so that, it can firmly stand. So on that note, we'll start with today's lecture. So we have, the topic, the most wanted topics, which are from coming from CBSE 11th standard, portions from your NCRT. So I always would strongly recommend all of you to practice all the questions from NCRT textbook, because NCRT is the fundamental basis for be it NEET or be it JEE. Okay, so based on that, now chapters solra. So those topics, please make a tick if you have the NCRT textbook with you guys. Okay, so the topics which play an important role are, if you see, you have motion in a straight line. This is very important. Motion in a plane is important, which is the third chapter, motion in a straight line, second chapter of your NCRT. Obviously physical world வந்து நம்ம consider பண்றதில்ல. So physical world வந்து நீங்க விட்டுருங்க, that is not there. Then you have motion in a straight line, motion in a plane, அதுக்கப்புறம் laws of motion, ஓகேங்களா? And then you have gravitation, then mechanical properties of solids, mechanical properties of fluids, thermodynamics, and these are the most important topics. So I have given you around 6 to 7 topics. So in these topics, you will have to concentrate more to ensure that you answer, you are able to handle majority of the questions that are asked from 11th standard portion. for your NEET, as far as the NEET is being concerned. So on that note, we will start off without any further delay. So the first chapter that I'm going to choose for today is the a chapter which is having the most weightage. So we will.
Sir, excuse me, will you please tell the chapters again?
Sure,
One
sure.
more time? Okay.
Yes, ma'am. Yes.
Okay. Okay.
Motion in a straight line. So I'll just jot it down here so that all the kids can see. I think that would be much better. I'll just write it here. So children, I hope all of you are able to see the screen that I'm sharing. It is a black screen where I annotate and solve the problems and write the questions. So the first chapter, I just put it here. Motion in a straight line. This is the first one. And then you have motion in a plane. This is the second one. And third chapter we have laws of motion. Fourth, work, energy and power. Fifth, gravitation. Sixth, we have mechanical properties of solids. Seventh, we have mechanical properties of fluids. And last but not the least, thermodynamics. Okay. So even before we start on with the curriculum, so I wanted to share these important topics, okay, with the entire batch so that you're aware about the core areas where you will have to concentrate. Okay, so there are around 8 topics, children, 8 chapters basically. So you will have to pay more attention for all these topics. Okay.
But one second, Manish. Students,
Ah,
we will be sending this video and in the our எழுதுற அந்த டாக்குமெண்ட்டுமே will be sent by the in your group. ஸோ அதனால் நீங்கள் காப்பி பண்ண முடியலனாலும் பரவாயில்ல, இந்த டாக்குமெண்ட் வரும். இல்லையா மனிஷ்? கேன் வி ஷேர்
yes,
திஸ்?
yes. It
Yeah,
will be shared in the groups, children.
yeah,
Okay, sir,
please.
sir will be putting it.
Yeah.
I'll be sharing it one of the groups. Okay, so it will be shared to all the groups. Need not worry. You will have access to all the content that I am explaining. Okay, so with that we'll move on. So today we will start off with the topic uh, that is laws of motion. We will start with this topic because this plays a major role again. So the most important one. So we'll start with this one. Okay, for today. So here we go. Okay, so laws of motion. Now this chapter, laws of motion, is more related to the fundamental basis. It actually dates back to your ninth standard topic, motion, which most of you might be aware of. CBSE guys will definitely have some idea about this. Okay, so where you guys would have learned what is rectilinear motion. You would have learned about the concepts of the Newton's first law and all that, and you would have learned about the Newton's second law of motion, third law of motion, so on and so forth. So there are different aspects to it. So today we'll be dealing with that, and then we'll proceed. So I'll give you the basics first, children. Each and every time we will be having a quick recap of the chapter. The summary of the chapter will be taught. The important concepts will be covered from the competitive point of view. So I request all of you to pay attention. If possible, you can also have a small notebook. Important concepts, important formulas you can jot down. Anyways, I'm writing here, no doubt, but still, when I'm going to ask you to solve any question, it becomes handy if you write the formulas and keep. So now we'll move on with the chapter. We'll start off from the basics and then we'll progress ahead. Okay, so here we'll go ahead with the basic concepts first before we jump deep into it. First and foremost, what do you mean by force? what is meant by force. I hope all of you might have some idea about it. Okay, so force is basically a push or a pull that's going to execute, that's going to displace an object from its initial position. So if I'm going to apply a force in an object, if that object moves, then you say that the force has been applied on it, and there is a displacement also in the direction of motion of that corresponding object. So just a push or a pull of an object is basically the force. That's a fundamental idea. And we have different types of forces in nature. So we'll see what is the different types of forces. So forces, I told you what it is. It's just a push or a pull. Just a basic idea. That's it. And then types of forces. So what are the different aspects? What are the different types of forces that we have? Any idea? Forces can be broadly classified into two categories. So anybody can take a
Conservative force
guess.
or not?
Okay, that is also one aspect. Now, in general, you can say forces are of two types. We have something called as contact forces, and then you have something called as non-contact forces. Have you guys heard about this? So you have contact and non-contact. Now, what do you mean by contact forces? The forces
Uh,
that, yeah. Go ahead.
Forces that are applied on a body when there is physical contact.
Yes, forces that are applied on the body, okay, and when they are in contact with each other. That's the most, important aspect. So that type of force, you call it a contact force. Absolutely. Examples of contact forces, anybody? What are the examples, most common examples that we come across in our daily lives?
Frictional force.
Yes, frictional force is a contact force, right? So when you basically try to push an object that is resting on a surface, now between the surface of the object, okay, and the ground on which it is placed, on the surface it is being placed, there is a force that is going to come into picture. When you try to push it, there is an opposing force to the direction of motion of the object. That is called the force friction. It is a resistive force. So that's an example of contact force. Apart from friction, again, so many are there. So contact forces, you have friction. Okay, friction is there. Okay, apart from friction, what about muscular forces? When you go to the gym and when you work out, don't you think you will have to pull weights, right? You will have to push objects, isn't it? So that's an example. So muscular force is an example of contact force. Okay, so muscular force. So like this, you have examples of contact forces, okay, etc. Non-contact forces. So in non-contact forces, the forces, they are not, in direct contact with each other. They actually act when they are apart. There is, a separation, a distance of separation between them when they operate. For examples, any non-contact forces, can anybody volunteer and tell me any
Mag-
idea?
Gravitational force.
Very good. Gravitational force. Okay, when you try to drop an object, you can see that the earth's gravity is going to pull it towards its center, and therefore gravitational force is a non-contact force. Very good. Apart from that,
Magnetic force.
magnetic force. Very good. Magnetic
Electrostatic force.
force. Yes, that's right. Electrostatic. Okay, have you seen when you comb your hair and you take it, uh,
Electromagnetic field.
yeah, when you take it close to tiny bits of paper, have you seen the, bits of paper get attracted to the comb? And how does it even happen? That's because of the static charges that are developed due to friction. When you rub the comb against your hair, okay, the hair follicles, then the tiny bits, then the comb gets charged, and when you take it close to the tiny bits of paper, the bits of paper get attracted due to the static, electrostatic forces. That's an example of non-contact. And somebody else told something, I didn't hear it properly. What was that? Electrostatic is right. Somebody told something else also. Electromagnetic, did you mean electromagnets? Electromagnetic.
Electrostatic.
Yeah, electrostatic is right. And after that, somebody was telling another example too.
So electromagnetic force.
Yes, that's also right. Okay, electromagnetic force. Okay, now these are all examples of non-contact forces. Electromagnets. Have you heard about electromagnets? How is electromagnetic different from electrostatic? Now, electrostatic is basically when electrons, when an object is being charged that is not in motion. Okay, and you try to take it close to an uncharged body, it attracts it. But when I say electromagnetic, now you know that magnets are objects that have the property of attraction or repulsion. Do you guys agree with me? Right? Magnets are objects which have the property of attraction. So when you bring an object under the influence of a magnet or in the region where its influence is being felt, you say that there is a magnetic force of attraction or repulsion that's going to happen. Okay, that's going to act with respect to the particle. Okay, so when I say electromagnetic, that magnetic force is created due to electricity. For example, solenoid is a classic example where you take a round coil, copper coil, and connect it to the ends of a battery. Then what happens? A magnetic force is being created, and therefore it can attract
Hello.
objects, metallic objects. Okay, so
Yes,
this is
Shatul.
something that you guys should have in mind. Okay, so with that we'll go ahead. So we now know what are the different types of forces. With that, let's proceed with the next part, the next concept. You need to understand what is inertia. Can anybody tell me what is meant by inertia? Have you heard about this term before?
Yes, sir.
Yes, what is it?
The inherent quality of a body to resist any change to its state of rest or state of uniform
Yes,
motion.
yes, perfect. Inertia is basically the tendency by which an object remains to be in the state of rest or motion. You call that as inertia. Have you guys experienced a jerk when a moving bus suddenly stops? Now, why do you think that happens? That is because of inertia. Again, a bus that is at rest when suddenly accelerates, again you experience a jerk. Okay, that's also because of inertia. Now, what is the reason behind all this? It's because when an object is going to, you know, resist its change in the state of motion, then we say that that concept, I mean, that phenomenon as inertia. For instance, when you're sitting in the bus, okay, and the bus suddenly, moves, the bus is going to be in motion, but we take some time, you know, to be set into motion. Therefore, we jerk, you know, backwards. That's because of inertia of rest. So we continue to be at the state of rest. Okay. So this is something that you guys should keep in mind. So inertia, in a nutshell, is basically by which the tendency by which an object the tendency by which an object in the state of rest continues to be in the state of rest or motion. Okay. So that is what we call as inertia. Now, this inertia can be classified into two broad categories. Okay, so we have something called as inertia of rest and inertia of motion. Okay, so inertia of rest is one, and then we also have inertia of motion. So these are the two broad categories of inertia. First one, inertia of rest and inertia of motion. What happens in inertia of rest? The object will continue to be in the state of rest. That is inertia of rest. I'll give you a simple example, an interesting one. You take a dusty carpet and you suddenly beat it with a wooden stick. What happens? The dust gets separated. How? That's because of inertia of rest. When you hit a carpet suddenly with a stick, the carpet is in motion, but those tiny dust particles on the surface, they continue to be in the state of rest. Okay? And that's how the dust gets separated from the carpet. So that's an example of inertia of rest. What about another example? You take a glass tumbler and you place, a a plastic card over it, and over the card you place a coin, okay, preferably a 5 rupee coin. Now, what happens when you flick the coin with your fingers? I mean, flick the card with your fingers. What do you observe? Does the coin fly away with the card, or does it fall inside the glass? What is your observation? Any guesses?
Inside the glass, sir.
Yeah, it falls inside the glass. That's because of,
So it falls into the glass.
yeah, it falls inside the glass. That is because of inertia of rest. The coin remains to be in the state of rest. You're getting it? So that's the concept of inertia. Okay, so like this we have different examples for inertia. So with that we'll move on. Having understood the basic idea, let's proceed further. Okay, so we're moving on to the next part, the fourth concept for the day. So we'll see Newton's laws of motion. Okay, so the basic idea of Newton's laws of motion. So have a quick recap of it. Okay, so you guys would have a pretty good idea about Newton's laws of motion. So today we'll have a quick recap of each one of them. So Newton's first law, second law, as well as third law. So let's look at Newton's first law of motion. First law of motion. So what do you mean by first law of motion? What is the statement? Can anybody tell me the statement of Newton's first law? If you can recall, it will be grateful.
Can I say it, sir?
Yeah, you can try.
A body will continue to be in a state of rest, a state of uniform motion, unless it is acted upon by some external unbalanced.
Yeah, yes, almost you're right. Okay, first law states that an object continues to be in the state of rest or uniform motion until and unless it is acted upon by an external unbalanced force. Now, why are they specifically telling unbalanced force? Because only then you can change the state of motion of the object. You getting it? So that's the reason an unbalanced force is necessary. So, for example, you take a wooden block and place it over the table. What is your observation? Will the block move on its own? Is it even possible? Until and unless you perform a magic trick, right? So the object is basically going to remain in the state of rest. But what if you're going to apply a force over the block? Provided you overcome the frictional force between the block and the surface in contact, then the block will definitely move. But what if you apply a force which is less than the frictional force? Can you expect it to move now?
No, sir.
No, it won't. So that's the reason an external unbalanced force is necessary, to make the block move. So this is an important
Manish, can I
concept.
interfere here for a moment?
Sure, sure,
See, very
sure.
interesting you have said, because in most of the books, even in Google, they say it is by the action of an external force. But what is more important, unbalanced external force. Am I correct?
Yes,
ரொம்ப
absolutely.
முக்கியமானது. I think it's a valid point you made it. Thank you.
Okay. So that's Newton's first law of motion. Okay, I'll just write it down here. An object continues to be in the state of rest or uniform motion until acted upon by an external unbalanced force. That's the basic aspect about it. So that's Newton's first law. Newton's first law of motion is also popularly known as the law of inertia. So if somebody is referring to law of inertia, it's basically Newton's first law that they're referring to. So that's also an important aspect. So it's also called as law of inertia. Okay, both are basically the same. You will not get confused. Okay, between first law and the law of inertia. Now let's move on to the second law, Newton's second law, which is very important. It has a lot of physical, significance in our daily lives. Let's try to understand that. Okay, so Newton's second law. So let's look at its statement. Okay, so anybody knows what is the statement for Newton's second law? You can tell me if you have an idea about it. Definitely,
An
the floor
object
is
is
yours.
equal to the rate of change of its movement.
Yes, that's right. Okay. Yeah. So to basically, make facts more clear, it is actually a fact. So always, the statements you will have to have an idea. That's right. What you said. It's basically a short form of Newton's second law. So the exact statement it goes like this: the rate of change of momentum, the rate of change of momentum of an object is directly proportional is directly proportional to the applied force. Okay, so the rate of change of momentum of an object is directly proportional to the applied force. So this is the fundamental statement of Newton's second law. Now here, I hope you guys have a good idea about what is momentum. Do you see there is an important term to be noted? So what is meant by momentum? Momentum is basically a physical quantity represented by the letter P. And the formula for momentum is mass times velocity. It is the product of mass and velocity, and the definition for momentum is it is the combined effect. Okay, it is the combined effect of mass and velocity of a moving body. Okay, of a moving body or moving object. Now this is very important. Why am I telling moving object? Only if an object is in motion will it have momentum. Do you guys agree to me? What if the object is at rest? Can it still have momentum?
No, sir.
No, it can't, because the formula itself tells you it's a product of mass and velocity. So if an object is at rest, its velocity is zero, and so does the momentum. So momentum would also be zero. So this is an important point to be noted. So if an object is at rest, momentum, there is no momentum. There is no question about momentum at all. Okay, so momentum is just zero. But if an object is at motion, it does have momentum. So that's an important point. Who can tell me what's the unit of momentum and how can we find it? Just from the formula, you can arrive at the unit of momentum. The standard unit of mass is kilograms, and the standard unit of velocity is meters per second. You combine both, you get the moment, you get the unit of momentum, which is kilogram meters per second, and that's the unit for momentum. Okay, so it's very interesting. See, from the formula you can basically understand what is the units of any physical quantity. Okay, that is the significance of physics. So now let's move on. Having understood what's momentum, now let's try to derive the equation for the second law of Newton. Now let me transform the Newton's second law statement into a mathematical expression. I repeat, I'm going to transform Newton's second law into a mathematical expression. How do I do that? Read the statement. Rate of change of momentum. How do I write that in mathematically? Change in momentum is delta P, and when I say rate of, I just need to divide it by T. Okay, so the rate of change of momentum is delta P upon T. Is directly proportional to applied force, which is F. Okay, so this is how we convert the statement into a mathematical form. And now we know that momentum has got the formula m times v, and I'm substituting that. So mass times velocity upon time, okay, is proportional to force. Now, when an object is moving from one part or one point to another point, does the mass of the object change? For example, you have a bus that is moving from point A to point B. Will the mass of the bus change as it reaches point B, or will it remain constant?
The mass will remain constant.
Yes, the mass will remain constant. Okay, so mass does not change. You all know that mass can neither be created nor be destroyed. So you can remove the mass symbol outside. So I can write this formula as m times delta v upon t is proportional to f. Now you can see that the rate of change of velocity delta v by t can be replaced by acceleration, right? Because the rate of change of velocity is acceleration. So you can write m times a is equal to f, provided the proportionality constant is taken as unity. And that's how we have derived the expression for Newton's second law as force is equal to mass times acceleration. Is that clear? That's how we do it. So this is the expression. This is how you derive the relationship for Newton's second law of motion. Now, here Can we write this in terms of momentum? Yes, of course, you can do that, because you know that acceleration can be written as your final velocity minus initial velocity upon time, because it's the rate of change of velocity, right? So we can write this as mv minus mu upon t. Now what is mv? Mv is nothing but momentum. To be more precise, it is a final momentum, because it's a product of mass times times final velocity, minus mass times initial velocity is basically initial momentum. So final minus initial momentum upon t. So final minus initial is actually the change in momentum. And can you see, we have got back our left hand side, which is delta p upon t. That is from where we started. Okay. So we have proved that force can also be expressed as the rate of change of momentum, and this is true. Okay. So now, having understood Newton's second law of motion, we'll move on to the next concept. Okay. That is the next law, which is Newton's third law of motion. Newton's third law of motion, I hope you guys might be knowing the statement. It's quite simple. Okay. So what's the Newton's third law? Anybody? The easiest
Every
law?
action has an equal and opposite reaction.
Yes, that's right. Every action has equal and opposite reaction. Okay. Every action has equal and opposite reaction. This is Newton's third law of motion. Okay. So what is this? What does this statement literally mean? If you have an action force that's acting, you have a reaction force as well. Okay. Classic examples. There are different examples to understand this. For example, you take a swimmer. Okay. So in a sport of swimming, you can see that swimmers, they push water backwards using their hands. Have you guys observed? When they push water backwards, basically it's the action that they're performing while swimming. They push water backwards, and upon doing so, they are moving forwards. Okay, so the action is the force exerted by the swimmer on water, and the reaction is the force exerted by water on the swimmer, due to which they are moving forward. So that's a classic example of Newton's third law of motion. Okay, so the swimmer was basically exerting an action force, and the reaction force is basically forward. So you have action and you have reaction. So both are acting along opposite directions. Yes.
But in this example, or for any other examples involving this statement,
Yeah.
when a force is applied, is the reaction force of the same magnitude?
Reaction force of the same magnitude. Reaction force not necessarily needs to be of the same magnitude. Okay, equal and opposite forces definitely are there, but if had it been the same magnitude, then the swimmer wouldn't move forward. He would just stay where he is, and they would cancel out, and the net force would totally be zero, right? So it does not be the same magnitude always. It depends. So, for example, if you're going to push the wall with your hand, what happens? The wall is not going to move, okay, because it has a lot of inertia. So it's not just going to move with the force that you're going to push it with. So but definitely there is an opposite force that the wall is also going to push you back. Now there, the magnitude is going to be equal, and the direction is also going to be opposite. But in this case, it's not like that. Okay. So the action and reaction force. So how much action you give, that much reaction definitely you are going to experience. So yes. So when you apply force on the water is also going to exert force over you, and that's how you basically move forward. And that is how the action reaction pair takes place. Okay. So majority of the cases, it is going to be equal, but not all the time. So that is something that you will have to keep in mind. Okay, so the conditions apply. So with that, we'll move ahead. Okay, so having understood Newton's third law, all the Newton's laws of motion, now we'll move on to some important aspect, about the next physical quantity called impulse. Okay, So you guys might be knowing, or for some of you, this term might be something new. Okay, impulse is basically the effect of force in a given time interval. So we can say this as effect of force for a given time interval. Okay, the effect of force for a given time interval, we call it as impulse. So it's the total effect that is acting of, the total effect of force being experienced by an object for a particular time interval or duration. You call it as impulse. It's given by the formula I equals F into T, where F is force in newtons and T is time in seconds. And what's the unit of impulse? Is Newton second. So that's the unit of impulse. Okay. Now impulse can also be expressed in terms of calculus formula. So I'll give you the formula of calculus also, wherein I is equal to integration t1 to t2 f times dt. So here f is basically your function and dt is basically the integrating factor. Okay. So this is also another way of expressing impulse for a given time duration. So with that, we move on. So just see the numbering. Let's check it out. 4 and this is 5. Okay. It's the fifth concept. Now we are moving on to the sixth one. So we have learned what is impulse. With that, we'll move on. Okay. We'll see what is the next concept, which is basically the law of conservation of momentum. Okay. Law of conservation of momentum. Now, what is law of conservation of momentum? We know that momentum is a product of mass times velocity. The combined effect of both mass and velocity is momentum. But what is meant by law of conservation? Which means the total momentum is going to be, before, is going to be the total momentum after, when an object is going to execute its motion. So the total momentum before impact is equal to the total momentum after impact. So that's the fundamental basis of this law. So we can simply say that total momentum is always conserved when total momentum before impact is going to be equal to total momentum after impact. Let's see examples for this. Okay. Impact and collision both are the same. Instead of using the word collision, I have used the word impact. So here, let us take a simple example. Okay. So let me say that I'm just taking a horizontal surface now. This is a horizontal surface, children, and I'm going to show a block that is there. Okay. So before impact, there are two blocks which are there. The first block is basically is moving. I'll just give the mass also. I just write it down there. The first block has a mass of 2 kilograms. The second block has a mass of 5 kilograms. Okay. The 2 kilograms block is moving with a velocity of 80 meters per second. Okay. So that's, and the 5 kilogram block is basically at rest. This is before collision. Now, after collision, both the blocks, they continue to move together as a single entity. Question is, what is the velocity of the blocks when they move together as a single entity? You get my question? But before collision, this is the scenario, or before impact. And after impact, both of them stick together and move as a single entity. So this is after impact. You just put it there. Now our objective is to find out what is the velocity with which both of them move together. Okay, so this is after impact. Now let's see how to solve this. Okay, such questions, how to approach and how we are going to solve it. Here we apply the law of conservation of momentum. How do we do that? You can see that the first block of mass 2 kilograms is in motion. right? It is moving at the rate of 80 meters per second, quite fast. But the block which is ahead of it, that is 5 kilogram block, is at rest. What do you mean by is at rest? That means your velocity, initial velocity is 0 meters per second. That is the meaning. Okay. So according to law of conservation of momentum, the total momentum before impact is equal to the total momentum after impact. We are going to apply that. So let me write the momentum for the first 2 kilogram block. And what is the answer for that? Product of mass into velocity. So I can write as m1 times u1. Okay, but that is the momentum of the first object, first block, plus m2 times u2. This is total momentum before impact. Should be equal to the total momentum after impact, which is m1 times v1 plus m2 times v2. Now this is the general formula, children. How do I apply this? Let us see. M1 is the first block whose mass is 2 kilograms. So 2 times the velocity is 80 plus M2, it is at rest, which means U2 is 0. 0 into 5 is totally 0, which is equal to M1 V1 plus M2 V2. But what is our condition as per the question, as per the scenario that is given above? Both of them are moving together. So the velocity V1 is equal to V2. Do you agree for the case given above? So I need to substitute V1 is equal to V2 is equal to V, because all of them are equal. Both of them are moving together. Therefore, mass of both the blocks will have the same final velocity after impact. And I'm going to apply that here. So I will get M1V plus M2V. Are you guys understanding? So we substitute. And 2 times 80 is 160 is equal to, you take V as common out, and M1 plus M2, how much is that? 5 plus 2 is 7. So V times 7. And what is the value of V? So V equals 160 upon 7. Who can tell me the answer in decimals? How much is 160 upon 7? You just need to go for a division. So you can divide and tell me in decimal places.
23. Roughly 23.
20, 23 or 24, right?
Yeah, roughly
Yeah.
23.
Okay. So 23. So approximately I'll put it as 23. So 23 meters per second. So you can see that when this 2 kg block moves and collides with the 5 kg block with a velocity of 80 meters per second, and if they happen to go move together, then the velocity that they will possess is going to be 23 meters per second, and that's how we calculate it. Okay, so this is how you basically do it, children. So that's the idea. Okay, so I hope this part is clear how to approach and solve such questions. Okay, so 22.8 you will be getting, okay, when you divide, so roughly it's 23 as told. Okay, so let's see another question. I want you guys also to try. It's quite interesting when you understand what's happening. So here is the question for you guys. Okay, you can try it out and get back to me with the answer. Okay, so the question is, yeah, I'll just give you the question so you can try it. Just choose one nice question. Yeah, here's the question. A metallic sphere of mass, a metallic sphere of mass just rephrase it. Metallic sphere having density, put it that way. Having a metallic sphere having radius, I'll put it that way, 3 centimeter, collides with So first metallic sphere, let me just name it as X. Okay, collides with another metallic sphere, and another metallic sphere Y. Okay, as shown below. So just depict it. So there is a metallic sphere X. This is sphere X. Okay, and this is another metallic sphere, which is, sphere Y. So you have two metallic sphere. So the metallic sphere X is basically colliding with the other metallic sphere, which is depicted here. So X is moving with a speed of 50 meters per second. Okay, and Y is also moving, this time with a speed of 2 meters per second, as shown. This is before collision. This scenario is before collision or before impact. Now, after impact, what happens is both the spheres X and Y, they move apart like this. So they move apart from each other. Okay. So X is moving apart with, a speed of v meters per second, and Y is moving with a speed of 2v meters per second. Okay, it's v and 2v. The question is, you will have to find out what is v and 2v. So here we have some data that needs to be given. I'm giving you the data also. So before collision is the first scenario, and the diagram which is above, and after collision is the second set of diagrams which I have drawn. Okay, this is after collision. Now the data that is given here to solve this question is, they have now given you the radius of the sphere X. Okay, radius of sphere X is basically equal to 1/4 of radius of sphere Y, which is Ry by 4. This is the relation that they have given. Okay, so this is what you have. And the density, both the spheres are made up of metal, which is copper, metal, and the density is given. I'll give you the density of the material of the spheres. So just I'll give you the value for density. Which is 8.96. You can take this as, appropriately, you can take it as 9. So it is 9 grams per centimeter cube. Okay, this is the density, children. This is the density of the sphere. Okay, density of the material of the spheres, basically. Okay, so you can tell me what is the velocity v and 2v. It's a competitive question, so you guys can approach. I want you guys to try it. Okay, I'll help you out. First case, before collision, X and Y are approaching each other. X is approaching with 50 meters per second speed. Y is approaching with 2 meters per second speed. Now, children, tell me in this question, even before you start solving, what is necessary? What data do you need to solve this question?
Mass.
Exactly. How can we find out mass? How can we find out the mass?
Density equal to mass upon volume.
Very good. Density is mass by volume. How can you find out the volume here? What will you use?
So the radius is
For
given.
5 3 per.
Yes. So you will be using 4 upon 3 pi r cube. That's right. Okay. So you'll be making use of that particular relationship, and then you will find out what is the mass. Yes, perfect. Go ahead, children. Solve it, and then tell me what is the answer that you are getting. First, you tell me what are the masses of both the sphere X and sphere Y. Okay. Now go ahead, solve it, children, and get back to me. We'll give you 2 minutes time, 2 to 3 minutes. You can try it out. The density of the material of sphere is 9 grams per centimeter cube. Please keep this in mind. You can see that density is not in its proper units, because mass, what is the unit of mass? I hope you guys know it is kilogram and not grams, right? So you guys should convert grams per centimeter cube to kilograms per meter cube before you proceed. So ensure that everything is in appropriate units. Okay, so units conversion is again a very important aspect, because you use directly 9, things will go totally wrong. So you should be very careful. Yeah, just keep trying. I'll just get back. Just give me 2 minutes. I'll fill some water and come. So please try it until then.
Students, new students, how are you feeling? Are you okay with the class? Are you in a position to understand whatever is taught? Initially, we'll go slow, and then we will move on to the questions and other things. Are you okay with this with the class? Okay, good. So if you have any clarification, you can express in the class itself, and we will take care. And you have to express everything in the first 1 or 2 classes. எல்லாம் முடிஞ்ச பிறகு பின்னாடி எக்ஸாம் வரும்போது பேசி பிரயோஜனம் இல்லை. If you tell something, we will make a necessary correction and give it to you, whatever is possible from our side. Okay? So that is the reason why in the initial classes, we ask people to express, be as expressive as possible. அவர் இங்கிலீஷ்லேயே தான் பேசுகிறாரு. ஏன்னா நான் தான் கேட்டேன். பிகாஸ் சம் பீப்புள் ஹூ கெனாட் அண்டர்ஸ்டாண்ட் தமிழ், ஐ திங்க் 1 or 2 ஆர் தேர். ஸோ அவங்களுக்காக நம்ம இல்லைன்னா அவர் கொஞ்சம் தமிழ் மிக்ஸ் பண்ணுவார் யூஸ்வலாக. பட் ஐ தாட் நோ லெட் ஹிம். கம்ஃபர்டபுள் தானே நீங்கள் எல்லாரும்? இங்கிலீஷ் ஒன்றும் பிரச்சனை இல்லையே?
Yes, children, I'm back. Okay, language பத்தி சார் சொல்லுங்க.
ஆமாம், இல்லை 1-2 பேர் அஃப்கோர்ஸ் நம்ம 1-2 தமிழ் இருக்காங்க. பட் அவங்க எல்லாம் நான் புரிஞ்சுக்குவாங்க. அவங்களோட லெவல் எனக்கு தெரியும். அப்சனா இருக்காங்க, தமிழ் தான், பட் ஷி வில் அண்டர்ஸ்டாண்ட்.
ஓகே.
எதா இருந்தாலும் குழந்தைகளா நீங்க எக்ஸ்பிரஸ் பண்ணணும் எங்களுக்கு. இல்லைன்னா எனக்கு தெரியாது.
எதுவா இருந்தாலும் நீங்க கேட்கலாம்.
டோன்ட் ஹெசிடேட். நீங்க இந்த ஸ்டேட் போர்டு குழந்தைகளுடைய பிரச்சனையே அதுதான். ஒன்றும் பேச மாட்டாங்க அங்க ஸ்கூல்ல. அப்படி இருக்காதீங்க. இங்க வந்து யூ கேன் ஸ்பீக் எனிதிங்.
இங்க நீங்க ஃப்ரீயா பேசலாம். எந்த ஒரு டவுட்டா இருந்தாலும் கேட்கலாம். எங்கேயாவது நீங்க ஸ்டக் ஆயிருக்கீங்க, சார் இந்த ஸ்டெப் புரியல, இன்னொரு வாட்டி எக்ஸ்பிளைன் பண்ணுங்க, ரொம்ப சந்தோஷமா ஐ வில் எக்ஸ்பிளைன். ஸோ வி வில் நாட் ஃபீல் பேட். வி ஆர் ஹியர் டு ஹெல்ப் யூ அவுட். சரிங்களா? ஃபீல் வெரி ஹாப்பி. Feel free to ask. Don't hesitate to ask questions. எவ்வளோ கேள்வி கேட்குறீங்களோ that much you are benefited. Yeah, யாராச்சும் ட்ரை பண்ணீங்களா? மாஸ் கண்டுபிடிக்கிறதுக்கு யாராச்சும் ட்ரை பண்ணீங்களா? What is the mass of sphere X? எவ்வளோ வந்துச்சு? ஒருத்தங்க கரெக்டா சொல்லியிருந்தீங்க. டென்சிட்டி வந்து மாஸ் பை வால்யூம் 15,200 kilograms.
16,200 into 10 cube pi.
Okay, 10 cube pi. Adellame we have to calculate. Okay, correct. Density is mass by volume. Check panna. So you can simply say mass வந்து நம்ம rearrange பண்ணோம் அப்படின்னா we will get mass equals to density into volume. இப்படி வரும். So therefore density questionல கொடுத்திருக்காங்க 9 grams per centimeter cube அப்படின்னு சொல்லி they have given. Here இப்போ நீங்க வந்து கன்வெர்ட் பண்ணணும். 9 grams per centimeter cube 9 kilograms per meter cube மாத்தணும். எப்படி மாத்துறது? அது வந்து ஒரு சிம்பிள் கன்வர்ஷன் தான். ஒரு நம்பரோட நம்ம மல்டிப்ளையோ இல்ல டிவைட் பண்ணோம்னா அதை ஈஸியா மாத்திடலாம். How to do that? அது வந்து எப்படி கன்வெர்ட் பண்றது அப்படின்றது தான் இஸ் வெரி இம்பார்ட்டன்ட். யாருக்காச்சும் ஐடியா இருக்கா? grams per centimeter cube to kilograms per meter cube கன்வர்ஷன்ஸ் படிச்சிருப்பீங்க. 1 gram per meter cube is equal to 1000 kilograms per meter cube. So you just need to multiply it with 1000. 1000 is a factor for conversion. So in the density வந்து substitute பண்றேன் 9 into 1000. 1000 ஏன் multiply பண்றேன்? Because I want to convert it. Because of conversion. Into volume. Volume வந்து 4/3 pi r we are talking about mass of sphere x அப்படிங்கிறதுனால நான் இது mx ன்னு போட்டுக்கிறேன். So it is r x by r cube இல்லையா? So rx cube image. You can keep it as rx. Okay. This is what you will get. இதை வந்து நீங்க simplify பண்ணணும். 3 ones are 3 threes are. So 3 fours are 12. So 12,000 pi rx cube. So you will get it like this. சரிங்களா? ஸோ இப்படி தான் உங்களுக்கு அந்த வேல்யூ வரும். நம்ம பை வந்து இப்போ நீங்கள் 3.14 கூட எடுத்துக்கலாம். அப்படி இல்லைனா பை வந்து 22/7 சாய்ஸ் வந்து உங்களுக்கு தான். ஸோ ஜென்ரலி ஐ டேக் 3.14. சரிங்களா? ஸோ யூ வில் டேக் இட் அஸ் 3.14 அண்ட் ஜஸ்ட் மல்டிப்ளை வித் 12. ஸோ 3.14 12 கூட நீங்கள் மல்டிப்ளை பண்ணீங்க அப்படின்னா ஸோ யூ வில் பி கெட்டிங் 8 6 carry over 7 37.68 வருதுங்களா? So you'll be getting 37.68. Okay, into 1000. Now the 12 could I just multiplied with 12. So into 1000 now your decimal places will shift, isn't it? So you will be getting 37680. Okay, 37680 rx cube. This is the mass of sphere x. Okay. Now here generally when you have a relationship உங்களுக்கு டைரக்டா ரிலேஷன் கொடுத்திருக்காங்க அப்படின்னா so you can assume one of them to be x and the other one of them to be unity and you can find out what is the other basic. So அதே மாதிரி my also நீங்க கண்டுபிடிக்கணும். So my what is the sphere of mass y, same logic யூஸ் பண்ணி நீங்க calculate பண்ணணும். So you know that mass of sphere y is nothing but go and substitute the values, okay, and then you try to simplify. So அதை நீங்க simplify பண்ணுங்க. ஓகேங்களா? Same way density, mass is density times volume. Density வந்து திரும்பியும் நமக்கு 9000 வரும். Okay, into 4/3 pi. This time ry cube. எல்லாமே simplify பண்ணீங்கன்னா திரும்பியுமே you will get 37680 ry cube தான் வரும். All simplification when you do it.
Sir,
except for the
4 times of rx.
Yes, correct. And now you will have to put in the place of ry you can put 4 times rx. That is where the important concept lies. So 37680 into 4 times ry cube. So you will get. Now is it just ry cube? You should be very careful here. நான் எப்படி டைரக்டா நம்ம போட முடியுமா? இல்ல. ry cube அப்படிங்கும்போது in the place of u1 velocity, how much is that? It is moving initially with velocity of 50 meters per second. So 50 na eppadi? Velocity is towards the right அப்படின்னா positive sign convention. Sign convention வந்து plus 50 mx. Second one is my. So plus my. But and the second sphere eppadi move agudhu? It is moving towards the left. It is moving towards the left with a velocity of 2 meters per second. Again, you should apply the sign convention. Something towards the left. You know that velocity is a vector, has magnitude as well as direction. Yeah. So I will write it within brackets as -2. So I will apply the sign convention here because it is a vector. Velocity is a vector. Is equal to, next m1 is again mx, the mass of sphere x, okay, times v1. What is v1? V1 is here, it is moving towards the left. After collision, you can see it is moving towards the left with a value of v meters per second, which we don't know. Okay, so left it is moving, so you take it as negative sign, so minus v plus my. How is that my moving? It is moving towards the right after collision with 2v. So times 2v. So substituting 2. இப்போ இதை நீங்க simplify பண்ணுங்க. So 50mx minus 2my is equal to minus vmx or mx into v. First v போட்டுக்கிறேன். So minus v times mx plus 2v my. This is how you get the equation. Equation form. Once you have formed the equation, now you go for the simplification. Okay, just you need to simplify it. Now, both your masses, you are having the relations here. You have to go and substitute the relations for the masses. Okay, the values whatever you have needs to be substituted. For mx 37680 r2 square. So t, yes.
Rx value 3. Why are we not substituting?
Pardon, rx?
Rx value, it's given as 3. Why are we not substituting it in the equation?
Rx value, where do we have Rx value directly? It is only Ry by 4, isn't it?
The radius of sphere 3 centimeter. Metallic sphere having radius.
Yeah, radius is 3 centimeters. Here they are specified, right?
Yes, sir.
Yeah. Why we are not substituting that is because both of them are, you have a relationship between them. Now, anyways, don't you think they will get cancelled if you're going to substitute here? Because both of them we have introduced in terms of Rx, isn't it? See, here also and here also. You get it? So, anyways, the terms are going to get cancelled off. When I go and substitute here, everywhere that Rx term, Rx cube itself will get cancelled. Are you understanding?
Yes, sir.
So I'm not substituting that value. If you substitute, you can, if you want, you can substitute, but that makes the calculation more tedious. So I'm not doing that. Okay. So 37680, I'm putting that 37680, and how much is that? Rx cube minus 2 times my is 241152. Okay, into 2, okay, is equal to into 2 Rx cube, basically is equal to minus v times whatever. Again, you have 37680. Sorry, so 37680 times Rx cube plus 2v times 241152 Rx. So now why I didn't cancel is because this gets cancelled. Everywhere you can cancel this term. That's the reason I didn't substitute basically. Okay. So now you will have to simplify it, children. 5 times 37860. You should multiply. Okay, you just multiply 5 times 37680. So if you multiply this, last terms 0, 0, 4, carry over 8, carry over 1. Is it 188400? So you will get this, and there is one more 0 also. I should not forget that. Okay, so one more 0. Fine. minus here. Uh, Basically, what are you having? Minus 2. 2 times 2 double 152. You just need to multiply it with 2, right? 4, 10, carry over 1, 3, 2, 8, 4. 482304. Okay, is equal to negative. So it's minus. Now here, children, don't you think you can take V as common out? Right? I'll take V as common out and then multiply 241152 with 2. Okay, which is again the same thing, I guess. So you will get 482304 minus, I'm putting the positive term first, okay, and then the negative term, minus 37680. That's it. So you have to subtract this and then go for a division.
Sir, here how the mass of Y is doubled in final.
Now the mass of
Mass of Y is doubled in final.
no, I have not doubled it. It's actually the velocity term, no, 2 meters per second. It
No,
is
sir,
m2u2.
in final
Final,
momentum.
final.
2 V my.
Yeah. So 2, where is that? This one, right?
Yes, sir.
This is 2v, no? It is moving with a velocity of 2v, right? After collision, see?
Oh, yes, sir. Yes.
Okay, it is actually moving. It's not, I'm not doubling the mass. Okay?
Yes, sir.
Yeah. So here now, children, you will have to substitute. You will have to subtract this 482304, okay, minus 37680. You will have to subtract. Once you subtract it, you will get 44444624e is equal to, again you subtract this left hand side term also. Okay, left hand side term. So again you will get a particular value which is 140169. Okay, 140169. Okay, that much times b, and then you divide it. What is the answer that you get once you divide this? So you divide this, you will get a fraction 186 by 59, which is 3.15. Okay, so the velocity is 3.15 meters per second. The value of v is 3.15 meters per second. So with what velocity will the sphere x move? It will move with a velocity of 3.15 meters per second, and the sphere y will move with twice its velocity, which is 6.3 meters per second. Is it clear, children? That's how you approach this question. Okay, so that's how you put law of the conservation of momentum into practice, and then we have solved this. Solution looks little, it looks little big, but once you start practicing such questions, I mean, you will have an idea about what needs to be done. Okay, that's the reason I introduced this question, so that you get an idea of how to solve it. Okay, so just to have an idea. So I hope you guys understood how to approach such questions, okay, with ease. So now we'll move on to the next concept. Okay, so here comes the next concept, which is force in terms of momentum, which you guys which you guys know it, but I'll give you the expression of force. Okay, so the expression of force in terms of momentum, it's calculus expression. Expression of force in terms of momentum. Okay, so F equals the rate of change of momentum, which is delta T upon delta T, which can also be written as dP by dt. Okay, so this is also the expression for force in terms of a calculus, representation, that is differential representation, dP by dt. Okay, the rate of change of momentum. I mean, it's basically the same aspect. We are putting it in a different term. That's it. Okay, so With that, we'll move on to a next concept, which is called as the Lammy's theorem. I don't know if you guys have heard about this. So Lammy's theorem அப்படின்னு சொல்லி ஒரு theorem இருக்கு, which is also important. Lammy's rule அப்படின்னு சொல்லுவாங்க. Some people refer it to as Lammy's theorem. So Lammy's theorem na என்ன அப்படின்னு பார்க்கலாம். So Lammy's theorem is basically when there are three or more concurrent forces that are acting. When I say concurrent forces, they will have a common point of origin. So say this is the origin, point O, which is common, and we have three forces. Say this force is F1, this force is F2, and this force is F3. Okay, so there are three forces, and the angles between the forces have been given as alpha. This is alpha between F1 and F2. Between F1 and F3 it is beta. Between F2 and F3 it is gamma. So when you have three such forces, மூணு force இப்படி act ஆச்சு அப்படின்னா with respect to a common point, அப்போ forceக்கும் இந்த angleஸ்க்கும் ஒரு relation இருக்கு. Okay, and the force and angle relation is given by Lammy's theorem. Okay, so it is nothing but F1 upon F1 upon sine gamma. Now how do I write sine gamma? The angle opposite to F1 I will write. Okay, so F1 upon sine gamma is equal to F2 upon sine beta is equal to F3 upon sine alpha. Okay, so this is basically Lammy's rule or Lammy's theorem. You have three forces having a common point of contact, then you can express the forces in terms of the ratios of the sine angles between them. So with that, we move on. Okay, so here is a simple question based on which I want you guys to apply the Lammy's rule and tell me what is the answer. Okay, now I hope you guys know what are pulleys. Pulleys na enna, I hope you guys have an idea about what pulleys are. Okay, so we have two system of two pulleys here. There are two pulleys that are fixed at point A and point B as shown in the figure. Okay, now there are ropes that are tied to either of these pulleys. Pulley A has got one rope, pulley B is also got one rope. These two ropes are connected at a point. They are connected together and these ropes are fastened. They are moving down as shown and they are connected to the blocks. This block is basically 5 kg block and this block is basically a 10 kg block, and in between it is being tied to another rope. Okay, there is another rope here like this, and you have another block that is tied to it. This block has got a mass of 15 kgs. Okay, this is the figure. Now you have to find out what are the forces, that is tension forces. Tension அப்படிங்கிறது it is a force that acts on the rope. ஓகேங்களா, இப்போ நீங்க ஒரு ரோப்ல ஹேங் ஆகுறீங்க அப்படின்னா, தொங்குறீங்க அப்படின்னா அந்த அந்த ரோப்ல வந்து ஒரு ஃபோர்ஸ் ஆக்ட் ஆகும். அந்த ஃபோர்ஸ் தான் டென்ஷன் ஃபோர்ஸ் அப்படின்னு சொல்லுவோம். when you basically are hung to a rope, the force is basically called tension force. This is T1, this is force T2. Okay, and here also there is going to be a force that is going to act, which is T3. Okay, so like this you have different forces that are acting. The question is, you will have to calculate what are the values of T1, T2 and T3. There is some data that I will give you. Okay, now the angle of inclination I am going to give. So I will give you the angle of inclination. Okay, the dotted lines that I am drawing are the coordinates basically. These are the coordinates. So x and y axis basically. So here the angle made here is 30 degrees. The angle made here is 60 degrees. Okay, this is all the data that you have. With this limited data, you will have to calculate what is T1, what is T2, and what is T3. How do you do it? How to calculate T1, T2, and T3? Let's look at this. Any ideas, children? How will you approach to calculate T1, T2, and T3? Okay. So, I mean, this is the first question that we are doing in this model. So, I will definitely help you out. Okay. Whenever you have questions like this, where they're asking you, the values of different forces that are acting. So, in that case, first you will have to resolve this diagram into a known component. Now, try to resolve it. Okay. Now, tension T1 அப்படிங்கும்போது the same rope is only going and connecting through 5 kg block. So, don't you think there is a weight component exerted by the 5 kilogram block, right? So there is a weight. What is that weight? You know that weight is equal to mass into gravity. So how much is the mass? Mass is 5. So 5 into acceleration due to gravity. I hope you guys know the value of acceleration due to gravity, which is 9.86, isn't it? So you will take that. So you will multiply 5 times 9.86. Okay, so you will get the value as 40, 50 varadu. So 49 something you will get, 49.3. Okay, so you get the weight as 49.3 newtons. So 49.3 newtons is basically acting downwards. Okay, this is a force of 49.3 newton. Same way for 10 kg block, how much force is going to act? 10 into 9.86. Simple, right? Which is going to be 98.6. So here 98.6 newtons will act. Okay, so that is the force that is going to act. When we have all this basically given in this question, so you can easily find out what is the tensions also that is going to act. Okay, so to find out the tension, here we have found out what is the weight that is acting. So therefore the value of tension that is going to act across T1, that is for T1 and T2, is something to do with the angles, right? So how do you do it out with the angles? At the bottom also you have one weight component, 15 kg. So your weight will be 15 times 9.86, which is going to act. So 15 times 9.86, you'll have to multiply and find out that value, which is 147.9. So 147.9 newtons of force. Okay, that is going to act vertically downwards. Now first calculate all the weights. We have calculated all the weights which are acting downwards. Having done with calculation of the weights, now we will go ahead and we will try to relate the tensions. Because you can see that T1 is making an angle of 30 degrees. So with the horizontal plane, but we want with the vertical plane. What is this angle, children? This is 30.
60 degrees.
This is going to be 90 minus 30, which is 60. Very good. 60. So T1 is making a component. I'm going to resolve tension T1 in terms of vertical components, which is T1 cos 60 degrees, and T2 is also going to make, if this is 60, this is going to be 30. So T2 cos 30 degrees. So there are two components that I have found out in the vertical plane, and the entire system is in equilibrium. So vertical component, there are two components, T1 cos 60 and T2 cos 30. At the bottom, you are having 15 kg mass, which is basically being tied, right? So that weight is 147.9. So I am going to equate that and going to get the relations between T1 and T2. So that's how basically we do it. Okay, so do it, children. Then you try to get the particular relationships. Okay, so try to do it that way based on the weight. Apply it. So here T1 cos 60 plus T2 cos 30 acting upwards. So T1 cos, just see the values, 60 and T2 cos 30. Okay, these are the vertical components. That should be equal to the components at the bottom, that is balancing, which is 147.9. So these both values will add up to 147.9. So this is one relation which we got. So you frame two equations and you can solve it. This is one approach. But if I'm using Lamy's theorem, now you see what happens. Okay, generally we do it like this. But when I use Lamy's theorem, can I write T1 divided by, what is the angle opposite to T1? Anybody? 60 plus, what is this angle? This is 90, right? How much is 60 plus 90? You get the answer directly.
150.
Yes, so T1 upon sine 150 degrees is equal to T2 upon, how much is that? T2 upon sine?
120.
120.
Yes, 90 plus 30. 120, that is sine 120 is equal to T3 upon, how much is that value?
90.
Okay, so T3 upon sine, so that angle is going to be 90 because 60 plus 30 is 90. So that is sine 90. See, directly Lamy's theorem gives you the relation between what is T1, T2 and T3. So by using this relation, you can find out the values, but for that you need the equations. One equation is here, this is equation number 1. Equation in 2 variables. Here also you have equation in 3 variables, which you can use 2 also and solve. Okay, so having 2 linear equations in 2 variables, you can substitute them, eliminate one of them and find the other. That is how you're going to do it. So who can tell me the relations between T1 and T2? Very simple. So T1 upon sine 90, I think you know. So T3 is sine 90. I hope the value is 1, right? So T3 is equal to T2 divided by, how much is sine 120? It is same as sine 60, right? Which is root 3 by 2, isn't it? So that is going to be root 3 by 2. So T2 is equal to, T3 is equal to T2 times upon root 3 by 2. So in other words, you just need to rearrange. So you will get this as T3 times root 3 is equal to T2. Okay, into 2. That is 2T2. Okay, just I have rearranged. That's it. Okay. If you want, you can just keep it like that. You even may not rearrange, just keep it that way. So we have got one relationship for T3 and T2. Here we have T1 and T2.